Some questions will be just straightforward moments questions and some questions will be principle of moments questions. So by the end of this section, you should be able to know when to recognise if a question is just a simple moments question or if you have to apply the principle of moments. So for simple moments questions, remember the formula is moments equals force multiplied by distance to the pivot. Now let's have a look at this one. A guillotine is used to cut through an apple. The second diagram illustrates the force used and some dimensions. Calculate the moment exerted by the 8 Newton force, which is here, about the pivot. Give your answer in Newton centimetres. So this is a 3-mark question, so it's relatively straightforward. Moments equals force multiplied by distance. Now that's the distance between the force and the pivot. So the force here is 8 newtons. Now its perpendicular distance to the pivot is 50 centimetres. Now it's the perpendicular distance, so that's why we ignore 60 and 65. So it's this distance here between the force and the pivot. So it's 8 newtons multiplied by 50 centimetres gives a moment of 400 Newton centimetres. Okay? Now, state the direction of the moment. So what way is this force moving? It's moving in an anti-clockwise direction. In this question, Deirdre, who has a mass of 450 newtons, stands at the end of a diving board. Calculate the moment of Deirdre's weight, which is 450 newtons, about the pivot when she stands at the end of the diving board. So if you have a look here, we have to give her moments in Newton meters, and that's fine because our distance is in meters anyway. So it's 450 multiplied by 2.5 meters. It gives a moment of 1,125 Newton meters. What is Deirdre's mass? Now remember, we're using another formula here. Mass equals weight divided by gravity. So divide her weight by gravity, which is 10, and she has a mass of 45 kilograms. This question is similar and therefore it's not too bad. So you can just follow the answers here whenever you're doing this. Now if you just look here, tick the box to show the direction of the moment of the 12 Newton force. Okay, the spanner is moving this way, so that would be a clockwise moment. For this question, it's a little bit different because you don't have to work out the moment here, you have to work out the force instead. So if you go back to your triangle and rearrange it, force is moment divided by distance. Now it tells you here that the moment is 300 Newton centimetres. Divide that by the distance between the force and the pivot, which is 20. So it's 300 Newton centimetres divided by 20 gives you a force of 15. So this question asks you to rearrange the moments triangle.